Hello, today we are beginning our short touch on statistics for the next several sections. And today we're looking at the fundamentals, so lots of definitions. Statistics is the science of collecting, organizing, and interpreting data. And statistics are the data that describe or summarize something. So this word statistics means two things. It's the science of collecting the data, and it is the data itself. The population in a study is the complete set of people or things being studied. Like if I were to study the entire United States, the population would be the entire United States. The sample is the subset of the population from which the raw data are actually obtained. Now, you couldn't interview the entire United States. That'd be pretty much impossible. So you would take a sample, a small group of the population. Population parameters are specific characteristics of the population that a statistical study is designed to estimate. And the sample statistics are numbers or observations that summarize the raw data. Example 1 says, describe the population, sample, population parameters, and sample statistics. Agricultural inspectors for Jefferson County measured the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn-producing farms in the county. So the population is all of those 104 corn farms in the county. Now, you wouldn't be able to test every single ear of corn. So they test 25 ears from each farm. That's the sample. The population parameters is what we're trying to measure, and that is the average levels of pesticide residue on corn in the county. And the sample statistics is the actual levels of pesticide. So the levels of pesticide actually measured on the corn sampled. Okay? Basic steps in a statistical study. First, you state the goal. Second, choose a representative sample from the population. When you choose a representative sample, like if you're sampling all of the United States, you're not just going to sample the women, okay? You would want women and men, for example. Unless you're only looking at something that has to do with women, of course. Collect data from the sample and summarize these data by finding sample statistics of interest. Use those sample statistics to infer the population parameters and draw conclusions. And here's just a little map you can look through. Example 2 says each month the U.S. Labor Department surveys 60,000 households to determine characteristics of the U.S. workforce. One population parameter of interest is the U.S. unemployment rate, defined as the percentage of people who are unemployed among all those who are either employed or actively seeking employment. So in the unemployment rate, they don't include retired people or elderly people or children or people that can't work. Okay? Only the people that can. Describe how the 5 basic steps of a statistical study apply to this research. So step 1, we want to state the goal. Lots of writing in this section. The goal is to learn about employment. Or really, unemployment. Within Americans who are either employed or actively seeking employment. I'd pause this while I was writing, but you guys are supposed to be copying this, so me leaving myself writing on here is giving yourself time to write it too. So step 2 says, choose a representative sample from the population. So in this case, the sample consists of people employed or actively seeking employment, in just the 60,000 households, because they can't survey the entire United States. The third step, collect data from the sample and summarize it by finding sample statistics of interest. So what would we do? The Labor Department asks questions of these people. In the sample. This is the data of the research. My hand's already hurting. And this data will be consolidated or organized into sample statistics such as, what are we measuring? The percentage unemployed. Step 4, use the sample statistics to infer the population parameters. So we're going to make estimates. Estimates are made to reflect population statistics, such as, what are we trying to estimate? The entire unemployment rate for the United States. And last, draw conclusions. So conclusions are drawn based on the population parameters. And any other information. For example, what are we usually trying to measure about unemployment rates? Well, whether or not there might be more jobs would be a conclusion we could make. So, for example, current and past unemployment rates may be used to draw conclusions about whether jobs have been created or lost. Okay. More definitions. A representative sample is a sample in which the relative characteristics of its sample members match those of a population. So if we're looking at the entire United States, you want people of all race, you want people of all gender or ethnicity or rich or poor, or everything you can possibly think of that would happen in the United States and throughout the entire country to be able to have a representative sample. A statistical study suffers from bias if its design or conduct tends to favor certain results. So if you just interviewed people in one area of the country and we're trying to say that represented the entire United States, that would be an example of bias. There are several different sampling methods. There's simple random sampling. We choose a sample of items in such a way that every sample of the same size has an equal chance of being selected. So if you had a hat, it would have to be a very big hat, okay, a swimming pool full of little pieces of paper with every name in the United States of people who are able to work, okay, then you could mix that up real good and start drawing out 60,000 names, and there you go. That's simple random. Systematic sampling. We use a simple system to choose the sample, such as selecting every 10th or every 50th member of the population. So I know we don't really use phone books anymore, but an example would be, used to, everybody's phone number was in a phone book. Can you believe that? An example would be going through and say, selecting every 40th person in the phone book. Convenient sampling. We choose a sample that is convenient to select, such as people who happen to be in the same classroom. So if we were trying to make some conclusions on the population of the entire community college, okay, then a convenient sampling would be just asking people in your classroom. That would be easy. And hopefully they would be a fairly good representation of everyone. Stratified sampling We use this method when we're concerned about difference among subgroups or strata within a population. We first identify the subgroups and then draw simple random samples with each subgroup. The total sample consists of all the samples from the individual subgroups. So if we were to interview everyone at the community college, you could break that between men and women if you wanted to. And these are just some pictures explaining those. Example 3. Here, we don't have any directions, but the directions are to identify which type of sampling is in each case. You're conducting a survey of students in a dormitory. You choose your sample by knocking on the door of every 5th room. The one where you choose every so many is systematic, because you choose every 5th room. This is representative if students are randomly assigned rooms anyway. To survey opinions on a proposed new water line, a research firm randomly draws the addresses of 200 homeowners from a public list of all homeowners. So this random, now when you see the word random, it doesn't always mean simple random sampling. We'll see that. But in this case, it's just randomly drawn. So simple random sampling. Agricultural inspectors for Jefferson County check the levels of residue from 3 common pesticides on 25 ears of corn from each of the 104 corn-producing farms in the country. Back to this example. So what is this? Well, since this one breaks it up by farm, then we call it stratified. Okay, because it's broken down from each farm and then could be put back together. And it's not stratus, it's stratified. Let me get rid of that S. And I need an R. Okay, now I think it's spelled right. And the last one, anthropologists determine the average brain size of early Neanderthals in Europe by studying skulls found at 3 sites in southern Europe. Well, obviously, you can't study every Neanderthal that ever lived. Yeah, not possible. But something that would be simple or convenient is sampling some that you have. So this is a convenience sample. So that was types of sampling. This is types of statistical studies. In an observational study, researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify these characteristics. In an experiment, researchers apply treatment to some or all of the sample members and then look to see whether the treatment has any effects. So observational, you're just observing. An experiment, you're experimenting. Just the way you would think those two words would mean. In an experiment, there's a treatment group and a control group. The treatment group are the ones that get the treatment. The control group do not receive the treatment. So in order to be kind of fooled into they could possibly be getting the treatment, oftentimes they'll get a placebo. It's important for the treatment and control groups to be selected randomly and to be alike in all respects except for the treatment. A placebo lacks the active ingredients of the treatment. Okay, so it would be like if I were testing out a vitamin on a group of 30 people, okay? I'd give 15 the actual vitamin and 15 one that looks like the vitamin. And I'd know who was who, or someone would know who was who, so that we could determine the results. The placebo effect. Well, sometimes when you give somebody a placebo, they think they're getting the real thing, and they might think they're getting better because of it. That's the placebo effect. Blinding. So blinding is the practice of keeping people in the dark. So if I'm going to give half of you a vitamin, half of you a fake vitamin, I'm not going to tell you who got what. That would defeat the purpose. That would be single blinding if you didn't know what you got, but I knew who got what. Double blinding is if you don't know and I don't know. Well, and so you kind of wonder, well, then how do you know? Well, you can give people numbers or to be able to match that up and go by numbers so you don't know who gets what exactly. Or a third party could come in and know who's got what. But sometimes double blinding is important, and we'll see why as we look at some examples. A case control study is an observational study that resembles an experiment because it naturally divides into two or more groups. So it's observational, but it's something that you couldn't have done an experiment on. Like, for example, if you wanted to see the effects of cigarettes and people getting lung cancer, okay? Well, you wouldn't assign 20 people to smoke real cigarettes and 20 people to smoke fake cigarettes, right? To observe that. No, you wouldn't do an experiment. You would do a observational study, but by observing people who didn't smoke and did smoke. And that kind of still looks like an experiment, though, the way it separates. The participants who engage in the behavior under a study form the cases, and the ones that don't are the controls. So cases would get the vitamin, the control group would not. Example 4, for the experiment described below, identify any problems and explain how the problems could have been avoided. A chiropractor performs adjustments on 25 patients with back pain. Afterward, 18 of the patients say they feel better. He concludes that the adjustments are an effective treatment. So, what could be a problem with this? Well, all 25 patients represent the control group. The treatment group. But it lacks a control group. Because they all got the treatment, sorry. So the question is, how could there be a control group? Well, this is what the book said. This is kind of weird if you ask me. It says, he could have hired an actor to help with creating a control group. So yeah, you want a fake chiropractor messing with your back. B says, a new drug for a type of attention deficit disorder is supposed to make the effect of children less disruptive. Randomly selecting children suffering from the disorder are divided into treatment and control groups. Those in the control group receive a placebo that looks just like the real drug. The experiment is single blind. Experimenters interview the children one-on-one to decide whether they became more polite. So, one problem is the fact that this is single blind. because the interviewers know who got it and who didn't. They may purposely or inadvertently if I misspell something, I'm sorry, interpret behavior differently since they know who received the drug. Did I spell? I think I spelled received wrong, didn't I? I can't ever remember that. And I know there's the I before E except for after C, but I don't know. Sometimes there's an exception. Okay. What's some other, so how could that be fixed? It could be double blind. We could have it double blind where the interviewers don't know who got what drug or who got the drug. Another problem I see with this is what they're measuring. Polite. Are people with children with attention deficit disorder necessarily less polite? I don't think that's an accurate measurement, because you might be polite with or without ADD, okay? Or you might not be with or without it. They probably should have measured something more specific to ADD, not necessarily polite. Example 5 says, for each of the following questions, what type of statistical study is most likely to lead to an answer and why? What is the average income of stockbrokers? Okay, well, is this observational or is it an experiment? Or does it kind of turn into a case control study? And if it's an experiment, is it double blind or single blind or what? So it's not an experiment because you're not going to go around and say, oh, you're a stockbroker and you're not, okay? You're observing the stockbrokers, so it is observational. We're just observing the income of the stockbrokers. Do seatbelts save lives? Well, you're not going to say, okay, you 50 people wear a seatbelt and go run into that wall with your car, and you 50 people don't wear a seatbelt and go run into a wall with your car. And let's see which ones of you die. No, that's not going to happen. So this is also observational, because it kind of it splits into two classes that kind of feels like a experiment, then it's actually an observational case control study, because one of the cases seems to be controlled, the people that happen to wear a seatbelt, and one seems to be not, the ones that don't wear a seatbelt. Even though you haven't assigned it, you're observing. Can lifting weights improve runners' time in a 10-kilometer race? Well, this could be either, but you could do it as an experiment. Okay? You can have one set of people lift weights, one set of people not, and have them run. Okay? Obviously, it's not going to be blind to anybody. It's just an experiment. Can a new herbal remedy reduce the severity of colds? Again, we can do an experiment with this one because you can give a placebo to part of the people and the real remedy to the other. And the most effective method for this experiment would be to make it double blind. Okay, just one more thing here, I think. The margin of error is used to describe a confidence interval, which we'll talk about more later on, that is likely to contain the true population parameter. What does this mean? So a confidence interval is like saying I'm 95% confident that somewhere between 40 and 45% of the voters will vote for Smith. Okay? That's a confidence interval. And the margin of error is added or subtracted from the sample statistics. So the sample statistics could be like the mean or the percentage of people that you've found for that not population, but for that sample, okay? And then you would add and subtract. So let's look at an example of that. An election eve poll finds that 52% of surveyed voters plan to vote for Smith. So these are just people that were surveyed. Not everybody that's going to go out to vote is going to be included in this sample. And Smith needs a majority, more than 50%, to win without a runoff. Okay? Well, you think 52%, oh, she's good to go. But it says that they've figured out, and you can figure this out, and we'll look at how later, but you can figure out the margin of error by, it's determined mostly by, or it is determined by the size of the sample, okay? So if your sample size is very small, your error is going to be very large. If your sample size is big, your error won't be as bad. So they figure the margin of error for this one is 3 percentage points. Will she win? So what we need to do is 52% minus 3% and 52% plus 3%. Okay? So if this were a 95% confident interval, we can say that we are 95% confident. There's 3 types of most commonly used confidence intervals, 90, 95, and 99, by the way. So we're 95% confident that the actual percentage of people planning to vote for Smith is between 49% and 55%. So, is she going to win? Well, this confidence interval, because of the 49%, because it goes down to that, it leaves open a chance for her to lose. More likely that she would win, it looks like, but it does leave open the chance that she would lose. Okay, So we're finally done with this pretty long section. As usual, email me if you have any questions.